Alright, we are ready to go, so make sure that magnetic force is in your science notebook, table of contents. Today is going to be a little faster paced as we start to get used to the idea of doing science first thing in the morning. So one of the things that, like I reminded you this morning, is when you come in, make sure you grab your science materials. You're going to find the table on the board. You need to make sure that you take care of that so that we're not wasting 5 minutes of our science time trying to get our science notebooks up to date. So just go ahead and update the table of contents. Go to the next blank page. Update your next investigation. Hey, Mr. Logan, is that up and going yet?
Yep.
Okay, then it needs to come to this table. Okay, it's one per table. All right, so today we're going to be looking at the magnetic force. So let's just kind of review very quickly some of the things that we've done over the last few days to make sure that we understand exactly what's happening. Yesterday, we were looking at a magnetic field. What was a magnetic field? Can anyone just kind of very quickly summarize what a magnetic field was or is? Vincent, what's a magnetic field? Okay. It's kind of like a little force field that is around a magnet. Okay. So what happens when magnets come close to each other, or when they come close to another magnet?
They repel and they attract.
Okay. They will either repel or attract depending on what?
The north. How you put them?
Depending on what we would call their orientation. North, 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 south, 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 right? So they're going to either attract or repel depending on that. Now, what causes the magnets to attract or repel? What causes that to happen? Rohan, any idea? Magnetism? No, it's not magnetism that causes it. Magnetism is what I call it. What causes the magnets to attract or repel? Serenity?
Inducing.
Inducing? No. Seth, what causes the magnets to attract or repel? The poles. Yeah. What is it about magnets that causes them to either attract or repel? Brayden? The magnetic field. The magnetic field around a magnet is going to cause the magnets to either attract or repel. Okay? Now, we know that the magnetic field has two poles, north and south. But it's not the north and south that makes it attract. It's, okay? Now, the next thing that we want to talk about, is there energy when magnets attract or repel? Is there energy there? Good question. How do you know? What evidence do you have that there's energy when magnets come close to each other? Vincent?
Because when we were first studying science, you said that energy is what causes something to do something.
Okay. So what evidence do I have? What evidence can I have to say that when two magnets come together, there's energy there? I know it. Why? Because what proof do I have, Kaylee?
Because when they repel, like they move from each other.
They move. Very good. Magnets move. When I bring two magnets together, a couple of things is going to happen. They're either going to push each other apart or they're going to pull each other, which creates motion. Movement means there is energy. Therefore, two magnets coming within proximity to each other, it's either going to repel or it's going to attract. But one way or another, it's going to create movement, which means there has to be energy. Because one of the first investigations we did, we discovered that when there is movement in an object, there is energy in that system. Okay, so let's come to our notebook and get our next section ready to go. And let's update here. That's not what I wanted. Delete that. So I'll just go ahead and write it in. Okay, so we're going to be looking at magnetic force. Okay, one thing I'm going to have you get into your notebook right now is that magnetism has two forces involved. Okay? And we're going to look at the names of the forces. Mr. Pearl's room? Yeah. I'm not... Which one's 15 and 16? Oh, yeah, I have those. I'll print them up and I'll send them up. Okay, thanks. Bye. Okay, so magnetism has two forces involved. Okay, one of the forces does what? Can you tell me what one of the forces does?
Repel.
Okay, one of the forces repels. So in fact, I would say you can't really see it. You can't see the force, so I would say magnetic force and fields is invisible. You can't see it, but you know it's there. Okay? So I'm going to say the force that pushes magnets apart is called what do you think I would call it? What would I call that force? We talked about it yesterday a little bit. What's that?
Inducing?
Inducing? No. So when we just randomly throw out science words because, oh, that's a word I learned yesterday, I'm going to throw it out there. Okay, that tells me that you don't what? Don't understand the word because I'm just using it without really thinking about what it means.
Repel?
Repel. Okay. So we're gonna take the word repel and actually make a bigger word on it. It's called repulsion. The repulsion force. Okay, the repulsion force. Now, come down here, and we're gonna say the force that pulls magnets together is called the attraction. We're going to take that word and kind of change it. Well, let's just keep it, the attraction force. Or we could call it the force of attraction or the force of repulsion. Okay. And a force is simply something that makes something else move. Okay. So in order for something to move, in order for there to be any kind of motion, you have to have some sort of a force that is going to do that. Okay. In order for a marker or an object to go up into the air, I have to apply a force to it. Where does the force come from? It comes from my hand. So I apply the force, the marker goes up. In order for something to fall, there has to be a force. What do I call that force?
Gravity.
It's called gravity. Okay, so in order to get anything to move, there always has to be some sort of a force involved. In magnetism, we name the two types of forces. We have the force of attraction, and we have the force of repulsion. Okay, so that's important. Now, what we're going to investigate today, right now, is that force of attraction. Okay, we know that magnets push each other apart. The question is, when they pull each other, what happens? Okay? So I'm going to go ahead and give you your focus question right now. Okay, so let's go ahead and get it in here. Here's your focus question. What happens to the force of attraction between magnets when the distance between them changes? Okay, so in other words, we're going to take some magnets, and we know what's going to happen to them when I bring them together. I know that when I bring these magnets together, the force of attraction is going to want them to stick to each other. The question is, what happens to that force as I change the distance between them? If I put the magnets really close to each other versus really far from each other, what happens to that force? Does it change or does it always stay the same? Is the force always the same? We don't know. So that's what we're going to investigate right now. Okay? So how are we going to do this? Well, in order to do this, we're going to have some equipment. Okay? So I'm going to show you what that equipment is going to be and how it's going to be used. Well, actually, I'm not going to tell you how it's going to be used. That is going to be up to you to come up with an experiment on how you're going to do this. Okay? So I'm going to set the materials down here on the let you take a look at them. Okay, what you're going to receive is you're going to receive a balance scale. Okay? A balance scale simply works as follows. One piece goes over the other, and when you look at it from the side, it just balances like this. And so in order for something to be equal, this would have to be balanced on both sides. Okay? So we're going to get into the specifics of how to make sure that you zero out your scale and that it's accurate. You don't want to start with your scale being crooked, okay? Because if your scale's crooked, then your data is going to be messed up. You want to make sure that your scale is balanced and it's zero, one side equals the other before you do anything. Okay, the other thing I'm going to give you is I'm going to give you a magnet on a post. Okay, you're also going to receive some cups. You're going to receive some metal washers, some plastic chips, and another donut-shaped magnet, which you've had in the past. Okay, all of these items are going to be sitting in these cups. So all you need to do is head on over to the science table. You're going to grab 2 cups, like this. You're going to grab a balance scale, and you're going to take that to your table. The other thing you're going to have, and Ms. Richards, you told me you didn't have these, so I'll send some of these up to you, so don't stress about it. Each group needs the procedures. Okay, these are the procedures that are going to tell you exactly what to do. Okay, so make sure you're following the instructions. If you're doing it right, you should be in good shape. And then a graph. Okay, you're going to take this graph and you're going to put it into your notebook, and you're going to take that data that you collect and you're going to put it in. You're going to put the data in the graph. Okay, and then what we're going to do is we're going to look at that data and try to figure out what it means. We're going to analyze and draw conclusions based on the graph and see if we can understand exactly what's happening to this magnetic force between magnets as we change the distance. Okay, any questions before we get started? Shaylee's not in here. Sophia, where are you? Can you run this up to Mrs. Richards' class upstairs? And she is right upstairs. You know where Miss Morgan's room is? Right above us. All the way down, last room. Okay? Yes.
When you give us the papers, do we have to glue it right away, or can we write in it first and then?
You can do it however you want, but you need to know where it's supposed to go. If you think you might lose it, I would suggest you glue it in. If you think you are not going to lose it, then you can hold off. Okay? For now, what I would like for you to do is for getter ones, to go ahead and go up to the science table, grab the materials, and start trying to figure out how could I test the force between magnets using those materials. Okay? So spend about five minutes or so trying to figure out an experiment that you're going to come up with. I'm not going to tell you how to do it. You have to figure that out on your own. Okay? So go ahead and get started and see if you come up with an experiment on how to do this. Okay? Remember, today's meet is available. Talk to each other, share ideas, questions, concerns, comments, and I'll also be on there to kind of guide you guys. All right? So good luck. Have fun. I'm going to go ahead and mute it on my end so that it's not a distraction in your classrooms. Okay, you should only have 2 cups. If you have an extra cup, put it back. You only need 2. you're going to test the force between magnets? You're speaking in idioms, not hyperboles. Idioms today. So what I want to do is I want to test the force between magnets attracting each other. So I'm going to test how strong that force is.
Don't get a single thing that's ever happened. It's Tap the dog.
No, we're not going to work. Okay. The magnet on the post, you do not pull the magnet off. That is attached. If you pull it off, you've broken it. Okay, so think about how you're going to test this. Now, how would this test the force of the magnet? Right now, we're trying to come up with an idea. Okay, so we're not trying to do anything right now. You're just trying to do this that way. You're testing. So don't waste your time. This stuff is fun. Right now, how could you test? Alright, let's stop. Hands on your heads. 5, 4, 3, 2, and 1. Any ideas on how I might possibly test the force between two magnets? And what happens when it's closer or when it's farther? Aubrey?
Start with it being even and start taking away.
That doesn't really tell me how you would test it. Okay, how would I test the force between magnets? Any ideas? Based on the materials that you have? No?
Maybe because yeah.
Any ideas on how? What's that? No? Brady.
take your magnet on the pole and place it in a circle?
All right, bring it up. Come on over. All right, so Braden's going to kind of walk us through what he thinks should happen. And bring it up to the front here. And kind of walk us through what you think you would want to do.
So my idea is you take your magnet on a pole and you put it in a circle underneath one of the cups.
Sorry, so make sure you're up there. Okay, go ahead.
Hold on.
Okay, so what you're doing is taking this off and you're putting the magnet on the pole there, which just happens to fit. That's a coincidence, right?
Or not.
Okay, now what?
Then you take your metal washers, probably put them in this side, but you should just start with one. And then you take your magnet and you place it in a cup and see how the magnet will attract when there's weight on one side.
Okay, well, is it attracting at all?
Well, it's attracting, but very little.
Very little. Okay, what if I were to take the weight out? What might happen to the magnet?
It might start to stick, and
Okay.
they actually did.
So you've got an attraction force that's keeping the magnet together. Now, how could I measure the force that that magnet has as it's stuck together? Serenity?
Put weight on the other side.
Put weight on the other side until it
Let's go.
until it breaks that attractive force. And then we would say, all right, it's washers to break the force between these two magnets, or whatever that is. We don't know. Now, how might I add space between the magnets to test what happens when the distance between the magnets is further apart? Any ideas? Okay, well, let's start off with that concept. Okay, so basically this is a pretty good idea. Okay, which is stick the magnets together, put weight on the other side until the magnets break apart. Now, that works out pretty well, but we need to make sure that the scale is balanced to begin with. Okay, you will notice that on your scale, on your balance, you have this little knob on one side, and on the other side you have this mark. Okay, you will also notice that on the bottom part of the scale, you also have a similar mark down here. When you put your scale together, it needs to be together like this. Okay, and the reason that's important is because this and this should line up. So once you take everything off your scale and you set your scale up like this, you should back up and look at it from the side and make sure that this mark here and this mark here are lined up. As long as they're lined up, you're in good shape. If it's not lined up, here's what you're going to do. If it's not lined up, this little plastic knob here can slide to the left, well, to my right, or to the left. And depending on where you slide it, if you slide it to the left, it's going to make the left side down a little bit. If you slide it to the right, it's going to make the right side go down a little bit more. So you want to basically set up your scale, check it from the side, and make sure it looks straight. If it doesn't look straight, move this little white knob till it's straight. Once it's straight, then you're now ready to start your experiment. Place the cups on both sides, connect your magnets together, put the cup on the other side, and then slowly start putting in washers until that force of magnetism is broken. Okay? And then in your notebook, you're going to want to collect that data. What kind of chart might you want to use to collect this data? Any ideas? Vincent? What might be a way to collect this data? A T-chart. That would probably be a good way to do it. A T-chart. With the space between them on one side and the number of washers it took to break it on the other side. Okay? So, go ahead, Braden, take this back to your table. Let's take a look at our notebook and see what that might look like. Okay, so in my notebook, I might come back and say, all right, so I'm going to create an experiment. And I'm going to put data, because this is the data I'm going to start to collect. And I might create a T-chart that looks something like this. I'll call this the space between the magnets. And then this is the washers that it took. If I stick the two magnets together, how much space is between them? If I put the cup, one magnet on the bottom, one magnet on top, and they stick together, how much space is there between them? Pretty much zero, right? So I would say with zero, in other words, the post on one end, the cup, and then the magnet, with zero spaces, how many washers is it going to take to break that force? And then I want to increase the distance between the magnet. How could I increase the distance between the magnets? Put what? Well, do you have any materials that you haven't used yet? Chips. So how could I increase the distance between the magnets?
Put the chip in between the magnets.
Put the chips in between the magnets. Now, okay, so I'm going to measure the space in what? In chips. So I might say, okay, with 0 chips, it took this many washers. With 1 chip, 2 chips, 3 chips, 4 chips, 5 chips. How many chips do you have? Count them. 6 chips? How many do you have? 6? Okay. Here's what I'm going to ask you to do. Once you do this, please do not, I repeat, do not collect data for this one. Okay, so I'm going to put a note here. Do not do. So what I want you to do is I want you to figure out how many washers it would take to break the force between the magnets with no chips, with 1 chip, with 2 chips between them. Are you going to do 3?
No.
You skip 3. Then you put 4 chips between them, 5 chips and 6 chips. So, why are you going to skip 3? You're going to skip 3 because what I'm going to have you do is after you've collected your data and made your graph, you're going to look at the data and you're going to look at your graph at what 3 should be. And you're going to make a prediction based on the data. Then you're going to come back and test 3 and see if 3 gives you what you thought it was going to be. Okay? So it's very important. You're going to learn to make predictions based on data and then test it later. Okay? So for right now, I'm going to give you guys about 10 minutes. Some of you guys are going to be heading if you want to, when you come back from band, we probably will already be done. But if you want to come in at lunch and do this experiment and collect the data yourself, you're more than welcome to. Or you can ask your team what the data was. Okay? Make sense? All right. Perfect. All right. So I'm going to give you about 10 minutes to start working on chips 0, 1, 2, 4, 5, and 6. And how many washers it's going to take to break that force. Okay? So you got 10 minutes. Alright, ladies and gentlemen, hands on your heads. 5, 4, 3, 2, 1. Alright, I do see a lot of you doing something I was expecting you to do, and so I want to talk a little bit about it. Okay? I've got some teams that are doing 2 different things. They do 0 chips, and they're dropping the washers into the cup. 1, 2, 3, and then, oh, it took 7. Then they add one chip in between the washer and the magnet, and then they're gently putting the washers into the cup. Is that going to make a difference?
Yes.
Whether you're throwing them in and then the next time you're gently putting them in?
Yeah.
Okay, so
It's more pressure.
yeah, if you're just throwing them in, it adds more pressure, okay, more force. Therefore, the magnetic force is going to break faster. Okay. Another thing I've noticed is some of you, when you're putting them in, you're using your hand to put them in. Okay. Why are we still experimenting? The other thing I'm noticing is some of you, when you're sticking your hand in, the force is breaking not because of the washer, but because you're pushing the cup down with your hand. Okay, so are you going to get accurate data?
No.
No. So in other words, you have to find a way to collect this data and make sure that you do it the same every single time. How do I make sure that my hand isn't the one that broke the force?
Don't let your hand touch the cup.
Okay? Kind of hard, right? Because when I'm putting the washer in, isn't my hand going to push down on the cup even if I try not to? My hand's going to push down. So what could I do?
Take the cup off and put a washer in, and then try that.
Okay, but then when I'm dropping the cup in, wouldn't my hand push on the scale?
Yeah.
It would. So I got to figure out a way to get my hand out of the equation. Make sure that my hand isn't part of the problem. So what could I do? Could I, Vincent?
Maybe you could maybe you could all get a piece of thread and then tie it to the washer and then untie it.
But
Yeah.
then when your hand still.
Then when you're
touching
untying it, you're going to have the problem where your hand is part of the problem, right? Okay, Serenity.
Maybe you could just pinch that.
Pinch them in, okay. But when you're pinching it in, is your hand going to push down on that cup?
Yeah.
Just let go.
It is. If you're letting go, aren't you dropping it in now? Okay, so it's kind of a problem that we have to address. Okay, Logan.
Maybe use your pick it up with your pencil. Yeah. Just put it in.
Okay, if you're carefully putting it in, is the washer going to fall into the cup?
Yeah.
It's still gonna fall into the cup. So we still got that same problem. So what do I not want to happen when I'm putting the washer in?
You don't want it to fall in.
You don't want
And
the
you
force
don't
to
want
break.
I don't want the force of the magnet to break because I was doing that. So what could I do to make sure the force of the magnet doesn't break while I'm doing that? How could I keep the force of the magnet from breaking? Put a chip between? No?
Put a washer in, then put the magnet back on.
No. Any other ideas? Could you hold the cup with the magnet down so it doesn't break?
Yeah.
Put the washer in very gently, and then gently lift your hand off the magnet and see if the force breaks.
Oh, that's a
Okay.
good idea.
So, in other words, when you're putting those chips in, when you're putting the washers in, have another person hold the cup down with the magnet to make sure the force doesn't break. Okay, what do I mean by that? Okay, let's bring Braden. Can you come up?
Sure.
Okay. So what do I mean by that? Well, what I mean is the magnet is here. Bring the magnet. Go ahead and drop it in.
Okay.
Okay. What you're going to notice,
Here's
bring me
some
your chips. Okay, so if I just start dropping the washers in, one. Oh, it only took one to break the force. Is that true?
No.
No. Why did that happen? Because I dropped it in. So, in other words, I need to start putting washers in and not want the force to break. Mr. Perla's room. Okay, we'll do. Thanks, Pat. Does anyone know Gwen's cubby number? Alaya, can you take her things to the office? Okay. So what we're going to do is basically this. Braden, you're going to put your hand up here to make sure it doesn't break. And I'm going to put the first washer in, like this. I'm going to move my hand, and then he removes his hand off for that. If the force doesn't break, then it doesn't take one washer. Okay, put your hand on there again. I'm going to do a second one. Okay. And now I'm going to do a third one. Okay, and I'm going to continue this process, and he's going to hold it down while I do the next one. Okay, let go. Hold it down. I'm going to do the next one. And we're going to continue doing this until the force breaks. And then I'm going to measure how many chips how many washers it took for that force to break. Make sense? Yes? Are we good? We clear? Okay, make sure you do it the same every time. Otherwise, if you're doing it differently for 0 chips or 1 chips or 3 chips, okay, it's going to affect your data. Okay, all right, so head back to your tables. Continue. You have 9
Hey
minutes.
Jason, can you take the top back? I'll take the bottom. That's why I said take the bottom.
Yeah.
Brayden, are these your chips? Let's not play. We're not doing that.
Hey, how about Brayden counts how many chips you have? And then I'll hold it down.
So what are you up to now?
Wait, you gotta get this out of there. 2. Okay.
Okay, so put it back. Hold on. I'll bring it over.
4.
Does it still hold it?
Yeah.
Okay, so hold it.
6.
And gently. Okay, so that's pretty much it. Now let go. Okay, is there any way you can get it to stay?
No.
No. Okay, so that's what it's going to take. So someone needs, how many is that?
6.
What group was Gwen in? Yours. How many people do you have now? Just 2? Okay. Can you guys work? Can you guys work on your own? Is that okay? All right.
Left on 13. 13.
So 13?
You got 13.
All right. So your first piece of data is
It's 13. It's 13. Did you jump that? It's 13. Wait, we got that was 13. Yeah. One check. 13. Yeah, you're right.
And so this is actually stuff that we talked about, but it'll help you to kind of look. Okay, this is stuff that we've already talked about. This is stuff we've talked about.
Okay, take off the chip. Okay, don't put it right here in the middle. Because the magnet will just
Because it has to separate.
So right there. Stop watching the script. Hang on. Write this down. Oh, wait. Chip in. 13. So space 13. Yeah.
Now, what does the directions say about where?
Washers 13. Watch this. Cannonball.
Put it back.
Cannonball.
Let it go slowly, see if it'll stay.
Cannonball.
It won't stay. So how many did it?
Lightly lift it.
Okay.
Say exactly where to put it. Okay, then you're good.
So collect your data. 0 spacers.
Oh, well, it shows a picture.
10 chips. 10 washers.
Okay,
Collect the data.
then you're good.
Okay, now collect the
As long as
data.
you're following those directions.
Ready? Wait, hold on.
So where did you add your spacers? Underneath. Okay. Are you guys doing one spacer? Where did you add your spacer? Underneath.
I'm finding the pattern there.
So what were you at the first time? 8. So let's make
Plus 1 space. Took 11 1. 9. So do it like that. Chip in the middle. Skip. Okay. Yeah. 1 washer. Okay, now put them. Mr. Kim, you just left the washer. Do you have 2 of them in there? No. Okay. Give me those ones. Give me the second that you read. Grade 6.
Or since you put them on the bottom.
Okay, so 6.
It's really good.
Now we're going to split up.
Yes.
Okay, ready?
Logan, let me see. Oh no, he's here. He must have forgot to go to bed. Let me. She is here. Oh my gosh, this kid forgot to go to bed today.
He left the note.
I know.
But you don't know why?
He told me he's no longer in bed. That's what he told me this morning. Okay. Okay. So Logan and Celeste. Okay, I'll send you down. All right, thank you guys. Logan, Celeste. Logan, Celeste. Aren't you guys supposed to be at band?
Oh, bye-bye.
See you guys.
See you later.
Wait, now we have to skip to 4. Remember, you said don't do 3.
Good. So.
We'll investigate 3 when we're done. I already read it. No, again. Sit in the middle. No, I think it was 7.
Do you have 4 spacers?
That's 3. Oh, wait. There is 4 spacers. 1, 2. Yep, you did right. Okay, now split them. Wait, 6, so 2.
No, we're not.
Yeah, magnitude.
Ready? 4.
Wait. Yeah,
Set. 1. James, aren't you supposed to go to band?
moving around.
No, actually, the only song I wanted to do with the trumpet, and the reason I wanted to go to band is that it was years. So,
Well, he's talking in hyperbole. Zachary is supposed to be talking in hyperbole.
oh yeah.
Wait. Alright, at least that song took very good, so.
One, 2,
And 4.
So now we're gonna put one spacer under the mat right here. Okay?
stop it.
Do that. And then we're gonna do the same thing. We're gonna swap. Washers.
Yes, now I'm at work. What? Wait, we're supposed to. It's supposed to be 3.
You guys, I want to do it.
You guys, wait.
I want to redo it.
Okay.
Why is
These extra.
I have a
I know. Oh, split. It's not even matched. I'm trying to fix it. Let's see if it
So you gotta add one more spacer right there.
I'm trying to fix it. It's not even balanced.
Okay, good. Add another spacer right there.
Got it. 1. 11, 8, 5, 4, 3.
Now, slowly add it.
So we each get 1. Take 1 of that. Wait.
Are you picking up your data?
No,
All right, ladies and gentlemen, by a show of hands, how much more time do you need to finish? 10. Let's go. 5 more, and that's it.
So, Mr. Perla, do you want him to do 3 if they have done their...
No. Do not do 3. Okay, once you have your data collected for all of them, do not do 3.
Why do we have to do 3?
Okay? You can go up to 5 kids, that's fine. Okay. Alright, the next part, for those of you that are done, I'm going to have getter ones. Come on up. You're going to collect one of these for all the members of your group. How many? How many? Getter ones for this table. Who is it? How about getter ones for this table? Who is it? Fine, you just need your shoes.
say to do it, right? We just turned out, gave you guys the pages.
Okay. All right, ladies and gentlemen, we're just about out of time, so let's move on. All right, time's up. Hands on your heads. 5, 4, 3, 2, and 1. Okay. All right. So I noticed here as I was walking around, I didn't get a chance to come back and look. But is there anyone at your table that is in charge of today's meat? Because there was a question posed, where do we place the chips? No one answered. Okay, we need to make sure that one person is in charge of today's meet, and they're constantly looking on there to see if there's any questions that you could ask your group to post. Okay, I think for the most part Ms. Richards' class figured it out. But again, we need to make sure that we have one person at our table that is in charge of today's meet. But let's go ahead and move on to the next part because we're going to be done here in the next 5 minutes. Okay, what I need you to do now is I need you to take your data and you're now going to graph your data. Okay, I'm going to come to the notebook and you should have gotten this graph sheet, this graphing sheet here. This graphing sheet is what you're going to use now. You're going to take your data and you're going to start to plot it. Now, on the bottom of my graphing sheet, I have, what are these here? Chips. So this is down here, spacers. These are the spacers I use. So I'm going to label that my spacers. What was I measuring with on the other side?
Washers.
Washers. So this is going to be the number of washers it took. Okay. Okay, if you're still playing with science materials, you will be done not only for today, you will be done for tomorrow as well. Okay. So what we're going to do now is we're going to come in and we're going to graph this data. So let me change the size of my graph here. Right. So down here, I'm going to keep track of how many spacers I had. So when I started, how many spacers did I use? I had 0 spacers. So I'm going to put, this would be 0 spacers. How many spacers was this line? 1. This was 2. This would be 3, 4, and 5. And then the washers, how many washers did I use? What was the highest number I had?
13.
13. So I can look at my line. So this is 0. 1, 2, 3, 4, 5. This would be 5. 6, 7, 8, 9, 10. This would be 10. And then 11, 12, 13, 14, 15. This would be 15. So at 0 washers, at 0 spacers, how many washers did it take? You're going to say, so for some people it took 13. So I'm going to say, okay, at 0 washers, it took 13. So I would come, so let's see, this is 5, 6, 7, 8, 9, 10, 11, 12, 13. So I would put a little mark right here because it took 13 at 0 spacers. Did anyone have 13 at 0 spacers? Okay. McKenna, you did. What did you have for 1 spacer? 6. So for 1 spacer, I'm going to go up to 6. 1, 2, 3, 4, 5, 6. My mark would be there. So at one spacer, it took 6 washers. How about 2? McKenna?
6.
At 2, it also took 6. So I would come to 2, and I would put a mark here at 6. Then you're going to do 4. What was 4? 4, it took 4. So 1, 2, 3, 4. So I put a mark at 4. And 5? 3. Okay, so this is what I have. Right? Okay, so what I'm going to do is then I'm going to take a ruler or a straight edge of some sort, and I'm going to connect these dots. I'm going to go from here to here, from there to there, from there to there, and from there to there. Okay? Now, once I've finished this, and I've done this, what I'm going to do is I'm going to look at this graph and I'm going to say, all right, so based on this graph, 3 spacers should be that point. Do you see that? Because that's where the graph crosses. So I would come across and say, what is that? That's 5. So based on the data, my prediction should be that 3 should be 5. Now, I don't know that because I haven't done it. I haven't done that yet. Okay? Tested 3, and that's what you got, then you're kind of ahead of the game. Okay? So that's what you're going to do. You're going to plot your data, draw your lines, look at where 3 matches that line, go across and make your prediction. Based on the graph, I think it's 5. Now I'm going to go back and put those 3 spacers and see if it is 5. If it's 5, then you know that that's the answer, and you found it using math, and you also found it using an experiment, which proves that your math was right. Okay, if for some reason the graph isn't right, then that tells me there was probably something wrong with your experimentations, because the math should have been pretty accurate. Okay, so go ahead and do that. Spend about 5 to 10 minutes doing that, and do it for today. All right, so I'm going to give you 5 minutes to do that. It should not take you that long to create your graph. All right, go for it.
13. Because 3 should be 5. Or somebody else. 3. No,
We should need 5 washers. I got 2.
Okay, where's the rest of your data? How about 2 spacers? What did you have for 2?
Yay!
I knew it.
It's not 5. My prediction was wrong. 15. I want to try and see this.
Yeah, because I'm using magnet.
I want to use iron.
So create your graph,
I want to see how that
prediction, and then test it. So create your graph quickly. You've only got 4 minutes. Got your graph?
Hey guys, look at
Where's your point for 4? And then you're going to draw a line from here to here.
Yeah, you know.
Oh my goodness, I made a huge mistake.
I'm just playing around. Watch this. I'm gonna try something.
Where does create your graph?
Magnet, you're trapped.
Okay, how do I
Which means it's going to be 4 or
We looked at our graph like that.
So now you're going to test it and see if it's 4 or 5. Hold on, rather than let's just start off with, let's look at
it was 5.
Here, you have 3 chins there. You want a 3.
10. So let's just start off with 10.
Does it break at 5? I want to make sure it doesn't.
Good.
Breaks at 5.
You have to connect them. I've lost it. You're gonna get a
Wait, need 3.
Okay, so you have 3. Okay, so now do this side.
I've lost yours. This is 4.
Now by 2, 3. And then just one at a time. Draw your lines and figure out which one. Okay, you guys make your prediction here? Can't have different numbers the same day. That makes you lose it.
In my back too.
I want to try this experiment but all over.
Before we did the graph, I knew it. Yeah, I did. Because he did it. No.
How the heck equal amount of
Probably
Ruler.
I'm not kidding.
You're done.
If you look at our graph data, it goes down by 4.
1, 2, 3, so on and so forth.
Yeah. So, but then it goes down to 3, and then it goes down by 1, and then it goes back down to 2. I knew it was between here, it's gone down twice. So I knew it was just going to go down to 1.
Okay, so this is what I want to try.
So, when I look at
I want to try to teach this experiment. I want to see how many washers it takes for it to actually break my washers. I mean, that'd be cool.
6, 4, 7. It's gonna be one of those two.
It'd be cool if we did the exercise.
Now test it.
Based on your graph.
Go to your reach and see if you get 6 or 7.
Is that what this says?
Let's just go quickly. Let's go quickly. So, you have 3 down there? Well, if I know it's going to be 6 or 7, then I should start off with not 1 chip. I should start off with 6 or 7. Why would I start with 1? Yeah. It should hold 5 at least. Because I know my answer is either 6 or 7. So how many is that?
I have washers. 3, 6. Everything science material is here.
Now my question is,
Okay.
Perfectly straight. How many washers do you guys have? It's a
So, the fact that one also tells me that I thought I did that. So, what did you get for 2?
But we can get washers this time.
And then you said that for 4 it took 5 washers?
Hey, do you guys
That doesn't make
you guys
sense.
have 5? We have 4.
I have 4 washers in there and it won't even hold.
For what?
So if I add 1 more, it's definitely
No, for 3. Oh, we need we have for number 3. Oh, we have 5. For number Miss Mayor. We have 4. Number 3. Cameron. Number 3, we got 5. Me too.
fine.
What did you guys get?
I guessed that right here.
So it holds 5.
And
We're good. So our prediction is that 6 or 7 is going to break. So let's test it.
Interesting that Hakeem is managing to break it at 4.
Okay, so your prediction is 6 or 7 is right. It's actually
Okay, you guys got 5?
6.
Some in the jar.
Alright. Alright, ladies and gentlemen, hands on your heads. 5, 4, 3, 2, 1. Alright, we're going to be finished right now. So, here's what I want you to do. After you have finished and you've made your graph, and you've looked at your graph, and you've made your prediction, and you've tested your prediction was that it would take 5 washers to break it 3. You test it. Did it take 5? If it didn't take 5, if it didn't take the number you predicted, then something was wrong with your experimentation. You might have not been putting the every time. Okay? So you can come back, if you want to come back at lunch and try it again, you can. But if you got your data to match correctly, then you were able to use math to make a prediction in science. Okay, let's stop playing with the materials. We're not in kindergarten anymore. Okay? Alright. Here's the final thing. I want you to look at this graph and draw a conclusion about what happens to the force of attraction as the distance changes. So look at this graph and say, what do I learn from this graph? Every time I added spacers, what happened to the distance between the magnets? What happened to the distance between the magnets when I added a spacer? Vincent?
You have to use those washers.
What happened to the distance between the magnets when I added spacers?
Big broke.
You're not listening to the question. What happened to the distance between the magnets every time I added a spacer? Jason.
The distance got bigger and bigger.
Yeah, the distance between the magnets was getting bigger, farther apart. Every time I added a spacer, the magnets were farther apart. What happens to the distance between the magnets when I decrease the number of spacers? The distance is closer. So when you look at this data and you look at the number of washers it took to break the force when there was 0, 1, or 2 compared to 5, what's happening to the force of attraction the farther apart the magnets get? Does it take more washers to break the force when they're closer together? Yes, Sedona? Or no? Why? Do you have evidence that that's true? You should. Do you have evidence that it takes more washers to break the force the closer they are? What's your evidence, Serenity?
The teacher.
Your T-chart? Okay. So you would say, with 1 spacer between them, it took 6. With 5 spacers between them, it only took 3. So it took less washers the farther apart they were. So what do you learn about the force of attraction between magnets? As the distance between the magnets, what happens to the force? It gets smaller. In fact, we would say it gets
Reduced.
It gets weaker. What happens to the force of attraction between magnets as I bring the magnets closer together?
It gets stronger.
It gets stronger. How do I know it gets stronger? Because the closer the magnets were, when I look at this graph, the closer the magnets were, the more washers it took to break the force. The farther apart I got the magnets, the less washers it took. Do you think at some point, if I put enough spacers, that they wouldn't even attract at all?
Yeah.
You think if I put like 10 spacers between them and I put it, it would just go, it wouldn't even attract?
Yeah.
So that force gets weaker and weaker and weaker and weaker the farther apart they are. The closer you bring those magnets together, though, the force gets really, really strong. Okay, if you take a look at my magnets, my really strong magnets that I have, my rare earth magnets. Okay, if I keep them really far apart, I can barely feel them pulling together. In fact, if they're far enough apart, I don't feel it at all. But as I start to bring them closer together, I can feel them pulling. And at some point, they get so close that there is nothing I can do to keep them apart. The force is so strong that I can't even keep them apart. If you were to say, okay, get them really, 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 really close without touching, at some point, those two magnets, when they're so close to each other, they're just going to pull, and they're going to attach to each other, and there's nothing I can do about it because the force is too strong for me to actually be able to stop it. Okay? So, in your analysis and conclusions, when you come into your reading block or your writing block, the question was as follows. What happens to the force of attraction of magnets when the distance between them changes? Do you know the answer to that question now? Yes, you should. Do you have data to back it up? Yes, you do. You even have a graph to back it up. Okay, so you should be able to answer this question now. And we'll take some time throughout the day, and I'll give you guys some time to do that. All right, so for now, we're going to leave it at that. So we are going to sign off. with Miss Taylor's class, or Miss Taylor and Miss Richard's class. Really? Let's see.
Brady's my brother very flexible.
Alright, so we're going to go ahead and sign off, guys. Thanks for joining us today, and we'll see you this afternoon.